Well, hello everybody. Welcome into Great Atmosphere here on February 2nd of 2024. I wanted to get started today by looking at our CONUS infrared map. We have our major system that's interacting with the Pacific coast and the Mountain West, currently interacting with a large ridge of high pressure that is sitting over the Midwest and the Great Lakes region. And then and that is itself pushing down as much moisture as it can out of the southeast. We're experiencing some high clouds this morning across the Carolinas, clear skies in Georgia, and generally speaking, quite cloudy skies across the Northeast. And if you don't know, February 2nd is Groundhog Day. It's when Punxsutawney Phil and other woodland critters are forcibly stricken from their homes to see whether or not they see their shadow. The bane of all meteorologists across the United States in terms of whether or not they're actually accurate or not. Turns out that the groundhogs are only about 40% accurate, and today all of them decided that it was going to be an early spring. So statistically, you can probably therefore say we are not in for an early spring based off of recent statistics and how the groundhogs have verified recently. But mainly, you can just pretty much guess what the groundhogs will say based on what the weather is outside on that day. Obviously, you can't see shadows without sun, and currently in Punxsutawney, Pennsylvania, it is quite cloudy, so therefore no shadows to be had, and thus the groundhog is forced to say early spring is en route. So, we're going to probably, or at least I'm going to make the case as to why that is most likely not the case based off of some of the things that we're seeing right now in terms of the long-term guidance. But we got bigger fish to fry. Before we get into that, first we got to take a look at the big atmospheric river impact that is affecting the Pacific coast. Now, this is the excessive rainfall forecast for day 3, so 3 days from now, from the Weather Prediction Center for the state of California. And you can see here there are this area in North Los Angeles and Orange County, a moderate or at least a 40% chance of exceeding flash flood guidance within 25 miles of a point. Now, some of these areas are expecting perhaps 6 to 10 inches of rain. This is primarily due to onslope flow, or upslope flow, I should say. Essentially, so the atmosphere kind of acts like a sponge when it interacts with high terrain. So let's say we have mountains here, and then atmosphere that goes like so. Okay, and the full depth of the atmosphere at and this is the surface level, right? So when there's no topography and it's literally just at sea level here, the atmosphere essentially can condense water vapor, or doesn't have to condense all these water vapor molecules that might be available, like here. See how they're very spread out, and there might be a cloud here or two here or there, but there's ultimately nothing that is ultimately forcing them to come together. And then when they run up and have upslope flow on topography, and the surface becomes something like this, all of those water molecules start to become much more condensed, literally condensation. And then we know that the next step after clouds form and it can't hold there, and there's just not enough space for the amount of water that is currently in that level of the atmosphere, means that more precipitation will come down over these regions. So that is what they're expecting as the flow comes off the southwest regions of the Southern California coast and up the mountain ranges in that particular region. So we can take a look at what this is the University of California, San Diego's Center for Western Weather and Water Extremes. This is an atmospheric river forecast. We can go out a little bit further ahead to be able to see what this atmospheric river is currently doing. We are looking at integrated vapor transport and integrated water vapor for these particular regions. And this kind of just shows how much moisture is being transported by an atmospheric flow at any given time. And in this particular graph, we're showing that over 1,100 kilograms per meter per second is being advected into the Southern California range. That's a lot of water. That's billions of gallons of water that is being advected over California right now. Ultimately, it's going to serve to increase the snowpack in the Sierra Nevadas, which is a good thing, and it'll fill up the reservoirs. Might flood some parts of the Central Valley if it can get up into the north enough. But ultimately, a lot of what the north has dealt with, they've already seen over the past couple of days, and it'll be more of a Southern California upslope flow event going into the next couple of days. Taking a look at what the icon is looking at. Now, fun news about the icon. Currently, the ensemble for the icon just became free and open use. Icon is a new global model, or newish global model, that is out of Germany and has done very, very well, particularly in the precipitation fields. So I'm going to be using that more and more as it becomes more and more available across a variety of different platforms. But one of the things that I thought was really curious about the forcing with this particular system is how it's going to originate and just how much extra forcing is going to be available to it in terms of energy. So we see that this is looking at today, is about right now, and we see that there is a low that is spinning off of the coast of the Cascadian Plateau and the Pacific Northwest, and that is slowly going to start dipping its way down further south. Now, what happens is it starts to interact with the upper-level jet stream, and that upper-level jet stream and the right-left quadrant will always, right-left quadrants of jet streaks will always propagate more convective initiation due to convergence at the surface and drawing air to the areas of diffluence in the upper levels. So a natural low is going to form as that upper level low that we can see here. If we can see this particular jet exit right here. So this is the upper level flow, the jet streak. I don't know if this is the particular right run. Let's see if we can get maybe to 8Z. That's a little bit better. So we can see if we cut this into quarters, like so. This is called quasi-geostrophic theory, by the way. So in this particular region, this is called the left exit region because the airflow is exiting off of this corner. This is areas where we are experiencing diffluent flow. So air is kind of going in a bunch of different directions right here. And anytime that air is leaving one particular region in all kinds of directions, that means that the atmosphere doesn't like voids, and it has to draw that air from somewhere. There's no air in the stratosphere above it, so therefore it has to draw in from the surface, and that's why when air is lifted from the surface, that is literally convective motion, and why we get low pressure centers to start to form. This is at the surface, by the way, so ignore that for the in terms of upper level synoptic patterns. So that's where the low pressure is supposed to be, where that is currently forming. So we have this at the surface level, as I'm talking right now. The surface level is right here. We expect a new surface low to form right here. Now, how are they going to interact with each other? Low pressures, actually, by virtue of the fact, even though they're low pressure, they do not have a very good time merging with one another due to the fact that even though they have cyclical cyclonic flows, if they come in contact with one another, it's not something that they can just merge. They will actually start to revolve around one another around a very, very awesome phenomenon called the Fujiwara effect, where they just start to spin and use one another's forcings to kind of jettison the other in different directions. And we can kind of see that here. So we see that surface low start to make its way down to the south, and we see the upper level jet streak start to form a new low in that quasi-geostrophic left exit region, or QG jet streak left exit region, start to form its own low right there. So you can see in this particular region we have our first low here and then a new low here. So what's going to happen is they're going to start to like revolve around one another like this. And the ultimate end result is this one's going to start to get more absorbed and become more of a shortwave trough, while this one is going to accelerate much faster upward. And when lows go from a area of low latitudes or like just closer to the equator, up into the mid-latitudes and upper closer to the Arctic. Whenever it does that, the wind fields tend to deepen. And if that happens quickly, that you can you can draw in quite a bit more moisture and have a lot more of a powerful system in place. So you can kind of potentially see that here, as you see. Wow, look at that. So you see that they start to revolve around one another, and then the low starts to deepen as it gets over and into the Northern California coast. And now, if the flow pattern were to be a little bit more eastward direction, and this parent low would start to move off onto the coast, we would expect a pretty significant deepening of that particular system. But it interacts with the landmass a little too much, according to the icon, and then it will start disrupting the Intermountain West, and hopefully delivering a good amount of snowpack for the Snake River Valley and hopefully Montana and northern Wyoming. So that is what they're looking at in terms of, and we always look at this in terms of what we're going to expect for rainfall. This is precipitable water, so if you were to take a 1 cubic meter cutout of the atmosphere in any particular region, this is how many inches of water would be in that cubic meter, essentially. And this is a good indicator of just how much precipitation the atmosphere is able to load in that particular region based off of a variety of factors. So in this particular sequence, we're going to kind of see where this river starts to form. We can see that parent low, that original low, start to make its way down further south, and the new low drawing in that Pineapple Express. You can literally see it clear as day right there. And that Pineapple Express, as we talked about earlier on in the week, is just a giant channel of moisture that comes pretty much straight from the Hawaiian archipelago, and the tropical jet stream and the trade easterlies down near the equator. And due to different synoptic motions in the mid-latitudes, will draw in that dense tropical moisture straight up into California and produce some significant rainfall. And that is exactly what we're seeing here. That is a classic Pineapple Express atmospheric river, and should result in quite a bit of rain for that particular region over the next 72 hours for sure. Taking a look at what's already precipitated across the region in California, we see Northern California near Eureka definitely seems to have gotten over the 6 inches mark. Now this is pretty much a rainforest in that of its own right, up in Northern California into the Cascadian Range and the valleys up there. But the main story will definitely be the Sierra Nevada snowpack. Midland Arizona, Phoenix definitely has gotten quite a bit of rain, and then down into Southern California, we expect these values to really balloon over the next couple of days. And we can see that based off of the Euro's precipitation forecast here. We can go take this all the way through the end of the event, which will probably be about Tuesday at noon. We see that areas in and around surrounding Los Angeles could expect up to 7 inches of rain. I believe the maximum forecast is 10 inches. That would be quite significant. I know a lot of the reservoirs and whatnot have already started releasing their outflows and whatnot, just to make sure that, in the event that things do overflow, they overflow in the way that they want and not, cause unnecessary landslides and whatnot. There will still be some flash flooding in areas that are flood prone and areas with impervious surfaces. But ultimately, this has been pretty well forecast for the past couple of weeks, and DSS support systems have been in place to make sure that they're going to handle this the best they can, and hopefully prevent something that was on the level of what we saw in San Diego a couple of weeks back. But also, in addition to that, we are going to be watching what's going on here in the Deep South and Central Texas and Oklahoma. A little bit of a severe threat that we'll potentially get into pretty soon. But before we get into that, I'm going to kind of take a look at some other stuff first. The one thing that I think is very important, and this is like, as meteorologists, you get a bunch of sometimes wackos that'll come up to you and tell you that climate change isn't real and all that kind of stuff. And while they present some arguments that are bad, but some arguments are actually good. And I think one of the ones that I definitely agree with the most, or not even necessarily agree with, but more like I think the people are kind of missing the point, is I'll phrase it this way. in terms of my immediate concern, like if as a person who's living in the 21st century, I am not totally as concerned with warming as I am with soil desertification. And I think that is probably going to be the thing that we experience as far as a changing weather climate and whatnot. Generally speaking, from a weather point of view, we would expect the atmosphere to be able to hold, as it gradually warms over a long period of time, no matter what the cause is, it'll be able to hold more moisture all at once. So when that happens, we're going to get more flash flooding events. We're going to get a lot more excessive rainfall events in areas that we probably weren't expecting to get it. This is already happening across at least the United States for sure, and it's across the world as well. You'll have convective rain bands that'll come in the spring and the summer, and or just even discrete cells that pop up, and popcorn cells essentially, and they're supposed to dump, according to model guidance, maybe like half an inch or 3/4 of an inch of rain, and instead they are going to drop 3 inches of rain. And that's just because the atmosphere is, generally speaking, a lot more capable of, holding a lot more moisture. And while that is, you might think, oh, it's good, it might rain more. Well, that actually is the opposite effect. It means that it can hold on to a lot more rain for a longer period of time before it has to let it all go. And that in that meantime, there will be more stretches in between that will ultimately, there will be essentially more drought in between these giant rain events that will occur less and less often. But it's like whenever we get rain, we're going to get rain. It'll be flooding, flooding rains, and then it won't rain at all for like 2 or 3 months, like that kind of ideation. And in that time frame, I mean, it's just a surefire way on both ends to desertify and stratify the soils that are worldwide, and it could be a particularly devastating agricultural phenomenon if we're not on top of it. So this is looking, all that to say, this is looking at soil moisture for this particular region of the United States. This is on a percentile basis through today. And ultimately, the areas that are highlighted in blue are in the higher percentiles of moisture, and then the areas highlighted in the reds, yellows, and oranges will be areas that are near the 2nd, 5th, 10th percentile in terms of moisture. So you would expect them to be quite dry soils. And going into the spring, which is obviously prime planting season, you obviously want to be on those high ends of soil moisture so that you can develop more of a crop yield. So right now we're particularly, we have been quite worried about the Mississippi River Valley, but there has been a good amount of drought reduction in that particular region over the past month or so that's good. And then specifically the next concern will be over in the deep southeast, and also making sure that Minnesota and Wisconsin get their fair share of snowpack in that they're definitely not getting due to the anomalous temperatures. There's quite a bit of concern, but that's all a digression to pretty much say, like in terms of what I think everyone's main concern should be, it should definitely be along the lines of soil stratification and desertification. That is certainly the much more impactful short-term problem for climate, I think. Taking a look at the next big thing in terms of what I'm concerned about here in the Southeast will be when is it going to get cold again? Here in Charlotte, where I'm based out of, we're currently in the longest snow drought of our existence at the moment. I believe we're at 720 days without any precipitation. It was January of 2022 when we last saw it here in the Charlotte metro. So we're definitely jonesing for some of the stuff, so I'm always looking at things that could perhaps signal the return of some colder weather, as we're currently experiencing quite a bit of mild air. Madden-Julian Oscillation is currently over. It's been over in the Phase 7 range in the Western Pacific, but new ensemble guidance is starting to kind of lean more towards the Western Hemisphere and Africa, Phase 8. This is kind of new. Generally speaking, it's been pretty much prohibitive in the Phase 7 region. When it gets into Phase 8, it can start to disrupt a lot of things in terms of getting cold air out of the Arctic and start to create more tropical systems a little bit closer to our part of the world. And ultimately, that it stands to essentially just be a phase disruption and move some stuff around so it could so we could possibly get some of the cold air that is necessary in order for us to get back to a traditional winter. Other things that you look at the Arctic Oscillation. Arctic Oscillation and the North Atlantic Oscillation. These are two different teleconnections that ultimately you want the unitless indices to be negative. Negative essentially means that things are disrupted, and thus you are more than capable of being able to get a little bit more colder Arctic air into your continental air masses. So you can see that the ensembles for the Arctic Oscillation are, generally speaking, for the GFS ensemble, generally saying it's going to shift negative here as we approach the middle of the month. And then, generally speaking, once these oscillation teleconnections are shifting negative for sure, that is when about a week after it takes for these to take effect. So then that would kind of precipitate hopefully a colder air mass coming down into the continental U.S. in the third to fourth week of February, unfortunately. But right now it's actually peaked out at the 3, if not higher, 3.5. That is a quite significantly high positive AO right now, and getting that to be disrupted will probably be quite significant and difficult to do. Not saying it's not going to happen. It's just it takes a lot of time and forcing to be able to happen. So that's why it's going to be a minute before any cold air could come back. NAO is definitely not as confident that it's going to be as big of a disruption on the Greenland side. Arctic Oscillation generally has more of a thing to do with the Aleutian Islands and the Bering Strait. So more of a neutral tilt, not necessarily saying one way or the other. It just, generally speaking, means that a GFS ensemble is having a hard time kind of figuring out what it's going to do, but it's pretty confident that it's at least going to go back into a more neutral state in the next coming days. We also take a look at the Nino 3.4 index. You can see the GFS wanted El Nino to kind of drop off quite dramatically as we enter into spring. Hasn't been the case. It seems to have peaked in around Christmas time, and it's been gradually going down in terms of severity as we approach into the third month of meteorological winter. So I would, generally speaking, expect it to kind of maintain that slow decline as we approach summer before things go more back to an ENSO neutral point of view. But the main thing that I definitely want to take a look at here is kind of way out in the European ensembles here with the 500 millibar height anomalies. So if we look at what we're looking at currently, we see quite significant ridging that is over the Great Lakes and the Hudson Bay and the Eastern Canadian provinces, and then troughs and low centers are pretty much all around us in the mid latitudes around in pretty much the contiguous U.S. So that is essentially the opposite of what we need in terms of forcing cold air out of the Arctic. What we need is these reds and yellows and whites to be over the areas that are quite cold. So in this case, Alaska and Greenland, and the areas surrounding Greenland and Iceland and Scandinavia. So because when high pressure ridges start to insert themselves in those particular regions, that means that the air mass has to move away from it. It literally just bullies them out of the way in order for it to be displaced. So you can see that is definitely not the case at the moment. But if we move way out in time, and it's always, you gotta understand what you're doing here when you're getting out to like 300 hour of a model. If you're ever going to do this, you definitely want to use an ensemble like this, and this is just to get an idea. But the general ideation here is, you can see near the 300 hour we see significant ridging, and this has been a connection that we've seen actually very consistently with the ensembles over the past week. Ridging returning in both Alaska and Alaska and Greenland, and ultimately serving to create more flow down from the Canadian provinces here. This could be, generally speaking, a good sign in terms of getting cold weather back here in the eastern seaboard of the U.S., because this is exactly the type of thing that would displace a polar vortex enough to be able to get that cold air to move, essentially. And you can see that in the CPC's weeks 3 to 4 outlook. This is for the middle months or the middle weeks of February. You're saying as opposed to what we're seeing now, which is quite anomalously warm and mild temperatures. The southeast should return to more of a higher probability of seeing below normal temperatures as we approach the middle portions of the month. And then also a good sign is that we have warm ridging returning to the Pacific Northwest, and Alaska will be quite above normal in terms of temperatures as well. Anytime that Alaska and Greenland are hogging all the cold air, it typically means that we're not getting any cold air here in the States. So ultimately, those are all things that are pointing in the right direction. Of course, if we're ever going to get snow, we need three different things to happen. We need moisture to be on top of us, we need cold air to be on top of us, and we need an energy trigger in order for it to happen. And unfortunately, it seems like we can't get all three of those things to happen at once. The current issue that we're dealing with here is we're in the middle of what is called a Rex block. We mentioned the high pressure that is currently sitting over the Great Lakes, and that high pressure system is kind of just stalled there. It's stalled spinning clockwise anticyclonically, and is ultimately kind of just sitting there, blocking any kind of flow that is making its way in. So you can see as we move forward in time, we expect that panhandle low to form in the lee side of the Rockies as we go forward into tomorrow and into Monday. And you can see typically when a panhandle low forms, it'll form like around here, right? And then it might dip a little bit, get down to the Norman, Oklahoma, Texarkana region, and then if there's nothing above it, typically there isn't, you would see it kind of go right through the Mississippi River Valley, through the Ohio, up into the Great Lakes, and go out like this, and completely missing the Appalachian Mountains. Now, that is not the case in this particular point of view. This time, we have high pressure ridging right here, the Rex block, as it's called, that is essentially just sitting right here, sitting and spinning. So it is blocking what the low wants to do, which is to go into the Ohio River Valley, and instead the low is now forced to go down into near the Gulf and the Gulf Stream, and then come up and do something like this. This is called a Miller Type B storm. And if we had, and this high pressure was bringing cold air along with it, and that cold air was available to be advected in from this particular region of the Canadian Prairie, then we would be getting cold air jettisoned in, right? And then we also have another high pressure system that is, a low system that is sitting off of Greenland right here, and originally it was funneling in cold air behind it. So we would have a cold air damming event that would be putting in all this cold air here in the Carolinas and the Piedmont of Virginia, in addition to the cold air that's being vected in for the Canadian province. And then we have our forcing mechanism, and we have our moisture return coming in from the Gulf Stream. That would have been a perfect opportunity for getting a significant snowstorm in the southeast. But unfortunately, we don't have the cold air because of that, because the polar vortex is strong and Alaska and Greenland are hogging all the fun. So that is just another frustrating aspect of it. Just to give you an idea of what the Rex block is, according to the National Weather Service, they are characterized by a high pressure system located poleward of a low pressure system. A lot of times it's called a high over low pattern, and they can happen over the Pacific Northwest, or the West in general. And then this whole system can essentially move into the eastern portion, eastern seaboard as well. And that is currently what we're experiencing: high pressure above, low pressure below, and ultimately that is what we're dealing with. Mild air specifically, and then we're expecting cool air to return, not necessarily anything wintry related in this particular circumstance. So, taking a look at some of our other threats that we're going to be seeing as we move forward in time, the next big one will probably be over in central Texas and Oklahoma as we go forward into Sunday and Monday night. Squall line pattern will start to form. Now, the interesting thing about this one is that it's actually supposed to be more of a hail event, and I can kind of describe to you why that might be by looking at a sounding that I pulled. But first, before we do that, I want to see this moisture return. Look at how much. These are dew points and overall moisture transport vector values that are coming in from the Gulf of Mexico. See these values right here? These are ridiculous dew points. Like 10 degrees. I mean, this is some of those dew points in that particular region are well over 60 degrees Fahrenheit, which is quite considerable for that particular region of this time of year. So it definitely has a lot of moisture, definitely has a lot of advection coming in off of it, and with that low pressure panhandle low starting to form, with the upper level jet pattern aloft, there will be quite a bit of forcing involved, creating somewhat of a negatively tilted trough, as you can probably tell as it moves forward. Didn't mean to do that. You can probably tell. Yeah, you can see the negatively tilted trough right here in that particular stance, forcing up meridional flow, essentially creating a cornucopia of severe weather parameters to occur here. Not so much of a tornado threat. There is an all hazards risk for this one, but particularly the main one is hail. So this is taking a look at Uvalde. This is the sounding that I pulled from the COD site just a second ago. And when you're looking for a hail parameter, you're looking for a couple of things. So you're looking for where the hail growth zone is on a parameter like this, and that's typically denoted by the negative 10 degree Celsius to negative 30 degree Celsius line. So in this particular sounding, they have the 30 degree Celsius line here, and you can anticipate the negative 10 degree Celsius line to be right here. So you can kind of like cut out this particular region, right? And then what you're looking for is you're looking for a large cape in that particular region in the hail growth zone. And you denote cape. Now, this is not an exact parcel, of course, because this is just a preliminary sounding. This is not an official sounding. But the parcel would be denoted by this line right here. And then that is juxtaposed against the temperature as seen. So this all right here is a significant amount. You take the derivative of that to be able to get the area of that region, and that's denoted as your cape value. That is quite a significant amount of cape. You can anticipate that to be the most unstable region of the atmosphere. This is where we're seeing 1513 cape. That is insane. A lot of convective inhibition, though, so it'll be interesting to see how much that actually pertains to be able to cap this, perhaps. But the main thing that it's kind of crazy is you also look at 700 to 500 millibar lapse rates. And essentially all that lapse rate is kind of like how fast that the atmosphere is cooling in one particular region of the atmosphere. So in this particular region, the 500, 700 region, which is generally speaking, the hail growth zone, even though it's technically supposed to be the negative 10 to negative 30 degree Celsius range, that particular zone is of import when it comes to lapse rates. And to have a lapse rate that goes 8.6 degrees Celsius per kilometer, that's ridiculous for hail growth. Typically, you want things that are just above 7 degrees Celsius, and that would be considered something that would be good for a hail growth parameter. We're well over that. We're closer to 9 than we are just 8. So definitely a hail system I would anticipate out of this particular one. And then also another thing you look for is a rotating updraft, which we definitely have according to our hodograph. And actually it's a little bit better off too, because we have the low level rotation, which could, precludes to that weak tornado chance. But also we get quite a bit of speed shear as well in a straight line hodograph as we go further up in the atmosphere. You can see that here we have relatively low winds coming out of the southeast before we get up to the mid-levels, and we're well over 50, 60 knots coming out of the west-southwest. So quite an interesting setup. Definitely something to be keeping in mind of, especially if you have people that live out there in Texas. You can see that the SPC has highlighted a slight region all hazards risk for going into tomorrow or Saturday night through Monday morning, I think is what it was essentially called. 2% tornado chance, 5% high winds. Mainly, we have that 50% chance of hail with a hatched region as well. That's new to me. And in that particular region, a 10% or greater probability of 2-inch diameter hail or larger within 25 miles of a point. That looks to be in the Del Rio, Eagle Pass, Uvalde, and Hondo, Texas region. Certainly something to keep an eye on. And I'm sure, I don't know if a lot of chasers will go and see that, just because there isn't a lot of tornadic activity to be expected out of it. I think a lot of people are expecting it to maybe tighten up a little bit more and become more of a northern Texas, maybe even Red River tornadic system. I think that's where they were expecting it to propagate a little bit more. But we'll see. It'll be something fun to track. Hopefully no one gets hurt over the course of the weekend. Taking a look at the temperature anomalies, We have, generally speaking, quite anomalously high temperatures throughout the course of the entire North American continent until that low pressure center comes in, and we know how low pressure centers work. We have both they block solar radiation, so we're getting a lot of cloud cover, and also this is bringing in colder temperatures, relatively colder temperatures from the continental Midwest, like this. So we're getting anomalously cold air, and then conversely, we're getting Gulf Stream air coming into the Midwest like that. So ultimately, that is what's driving a lot of that temperature change. And you can see, as far as like the pattern of where that low is going to go, we can see it start to form in the Gulf, make its way across Florida. Maybe a little bit of a severe threat for the Florida Panhandle, Jacksonville region, Gulf Coast states in general, perhaps, as we move forward into Monday. But ultimately, shouldn't be too much of a concern for the Carolinas as you move forward. And I think we can actually see, just by virtue of the dry air, where that's going to be, because obviously if you have dry air in place, you're not going to be seeing much of any precipitation. And you can see the Carolinas are pretty much walled off, with the exception of the Charleston region, from any kind of deep moisture. Well, South Carolina gets a little piece, I suppose, but North Carolina and Virginia largely left out of this system as we move forward next week. And if this low starts to deepen a little bit more off the Carolina coast, you can expect some more gale force winds, rip currents to be a little bit more of a problem across the eastern seaboard and the beaches going into the beginning of next week as well. So we take a look at our temperature anomalies. We're still very much warm in the next 0 to 5 days across the majority of the contiguous U.S. We still have our anomalously cold temperatures in Greenland and Alaska, and then we have our atmospheric river event bringing down temperatures across the west coast. But as we go out into days 10 and 15, we can still see, generally speaking, lower anomalously high temperatures, but displacement. We see a little bit of displacement in Greenland and Alaska, and also the temperatures in that of themselves are not as highly anomalous as before, so they're much more seasonal as we get into the middle parts of the month. Perhaps even so into the latter portions of the month. We can take a look at what the Climate Prediction Center is currently looking at on a 6 to 10 day scale, quite above normal in both precipitation across the country, with the exception of the eastern seaboard, and temperatures well above average across everything except for the west, except for the Mountain West and the Pacific Coast. Same graphic essentially applies for the 8 to 14 days, but then we get out into the weeks 3 to 4, and we see that precipitation chances increase across the south, with lower or higher chances of below normal temperatures in the southeast. You need to take a look at the 1 month, about near normal, 3 month near normal for the southeast, perhaps a little bit more wet. That's what they're currently looking at for the spring. So that's generally what we're looking at today. I apologize if I sound a little bit stuffed up and getting over a little bit of a head cold this week, but I am glad I was able to do this. This is some really interesting stuff, and we touched on a lot of topics today. Particularly interested to see how much rain falls in the California region today and into the weekend. It should be quite a significant atmospheric river event. Hopefully everyone over there stays safe, and we've planned accordingly for it. But ultimately, my name is Zach. I'm Zach for Great Atmosphere. I appreciate you tuning in. I'll be doing forecasts like this pretty much every Monday, Wednesday, and Friday. Primarily focused on the southeast, but if we got other stuff going on across the country, I'll definitely be talking about that as well. But I appreciate you tuning in. I appreciate your subscription if you're interested, and I will see you again next Monday for another forecasting video. Take care. Have a good weekend.